Hello class, today we're going to talk about the Pythagorean Theorem. Now, you are going to use this a lot next year in your geometry class, but we're just going to introduce you to the idea of it today. So, two learning targets today. We're going to find a side length of a right triangle given the lengths of its other two sides. And second, we're going to apply the Pythagorean Theorem to real-world problems. Let's do it. Now, when we're dealing with right triangles, all right, here's what I want you to see. Typically, the right angle is called angle C. And then what you should notice is the side opposite of each angle uses the same letter, but typically with a lowercase. So the angle is an uppercase C, the side opposite it is a lowercase c. Here, we have angle B. The side opposite angle B is lowercase b. And last we have angle A, and then the side opposite angle A is side A. All right, so this is how we typically label triangles. It helps us to keep everything neat, all right? A and B are typically called our legs. Our longest side, which will always be C, because that's across from our right angle, is called the hypotenuse. So leg, hypotenuse. And again, we use angle C on the right angle. A and B, it honestly doesn't matter which angle you call which, but we need angle C to be on the right angle. So, how are we going to use this? If given a right triangle, something like this, okay, and again, we call the right angle C. If given a right triangle with legs of length A and B and a hypotenuse of C, then A squared plus B squared equals C squared. That's the Pythagorean Theorem. Now, here's how this is useful. It's useful in really two ways that I want to show you at least now. I mean, this is useful in many, many, many different ways, but for our purposes, just two for now. So as you can see here, I have a right triangle, all right? And the side opposite that is just x. It's an unknown length. Well, using the Pythagorean Theorem, a squared plus b squared equals c squared. We can plug in the values we know and solve for the value we don't know. One of the legs, it really doesn't matter which one. We'll call A, 10. The other leg will be B, 7. And then the last one will be X, which is our unknown. So, 10 squared is 100, plus 7 squared is 49, is equal to X squared. So 149 is equal to X squared. And let's just get the decimal approximation here just to keep this a little simple. Take the square root of both sides. X is equal to approximately, the square root of 149 is approximately 12.21. So we know that this side length is approximately 12.21. Now we're doing the same for these other two. Again, what you need to be very careful about though is that C squared, that needs to be the side length opposite the right angle. So here it's going to be that y. Here it's going to be, either way you look at it, that z. All right. So as long as you set it up correctly, the Pythagorean Theorem will work. Now, we can use another version of the Pythagorean Theorem, like this. Let's say I give you a triangle. And this triangle, just keep it simple, we'll say this side length is 3, this side length is 4, this side length is 5, and I'm asking you, oof, that's horrible. And I'm asking you, is that a right angle? Well, if it is true that a leg squared plus another leg squared equals the hypotenuse squared, then that has to be a right angle. So does 9 plus 16 equal 25? Well, yes it does. Since the Pythagorean theorem works, we know that is a right angle. Great, do your homework.